Good morning. Before we start lesson 7 today, I wanted to start with a little bit of a warm-up. A lot of kids get stuck at this point when they're doing tape diagrams. They'll draw the tape, they'll put the total, they'll put the boxes, and then they get stuck. So we're going to practice just a second. When you have a tape drawn with the boxes and the total, I want you to just practice getting what you would put in the box, okay? This is thinking through a division fact. So write a division sentence. This first one, 10 divided by 2 boxes, and I'm going to write this up to the side. 10 divided by 2 boxes would be 5 in each box. Okay, you can do them out loud with me if you want at home. 9 divided by 3 boxes would be a 3 in each box. 8, what would it be? Divided into 4 boxes would be a 2 in each box. Okay, think this one to yourself. 25 divided by 5 boxes would be a 5 in each box. 40 divided by 1, 2, 3, 4, 5. 40 divided by 5, 8s. 42 divided by 6 would be a 7 in each box. Okay, a lot of times, so many students get stuck at that point. So I want to get you to where you can get past that. Okay, just a little bit more warm up. If you see this phrase, a half of 4, you can think of that as 4 divided by 2. Could also think of it as 4 divided by 2 written this way. 4 divided by 2 is 2. A half of 4 is 2. A half of 10 is 10 divided by 2, or 10 over 2, which is 5. A half of 10 is 5. A fourth of 16 would be 16 divided by 4, or 16 over 4. If you're thinking a fourth of 16, it's 16 over 4, which is 4. A fourth of 16 is 4. A third of 9 is 9 divided by 3, or 9 over 3, which is 3. Okay, one more. A third of 27. Think about it. What would it be? 9. Yes, that would be 27 divided by 3, or 27 thirds, or over 3, which is 9. Okay, just a little bit of warm up before we jump into the lesson today. Okay, we're going to be on the application problem first, which is on page 161 in your blue book. So go ahead and find that. Page 161 in your blue book. All right, this one you should have no trouble with, and I would like you to try this before you watch the video. Okay, so go ahead and do it. It's super easy. Mr. Peterson bought a case, which is 24 boxes of fruit juice. 1/3 of the drinks were grape and 2/3 were cranberry. So hopefully you've already started to draw your tape. It's told us there are 24 boxes of fruit juice, and we're dividing them into thirds. 1/3 was grape, so I'm going to label that. 2/3 were cranberry. Okay, now remember, this is what we just practiced. What goes in every box? 24 divided by 3 boxes would be an 8 in each box. Okay, so how many boxes of each flavor did he buy? Okay, so he bought 8 grape and 8 times 2, or 16 cranberry. Okay, that's all there was to that one. Super easy. All right, let's move on to the lesson for today. So you can turn the page, and we'll be on page 163. I'll let you take a look at that for a second. It's going to be a lot of tape diagrams today, which is great. I love them. Okay, so let's jump right in. Again, this a lot of this is stuff you've done before with those bean problems. Okay, we're solving using a tape. It says 1/3 of 18. Okay, again, remember the total is after that of. The total in this problem is 18. And we're dividing it into thirds. And we want to know what one of those is, 1/3. Okay, well, remember 18 divided by 3 is 6. That means 6 goes in each box, but I'm wanting one box. So the answer would be 6. I'll put the answer here. 1/3 of 18 is 6. Okay. 1/3 of 36. Leave myself room for the answer there. Okay, again, we put my total is 36. I'm dividing it into 3 boxes and then thinking to myself, what is 36? I'll do that over here. Divided by 3. That would be a 12 in each box. And I'm asked for 1/3. I'm asked for one box. So the answer would be 12. Okay. 3/4 times 24. I want you to notice that these mean the same thing. 1/3 of 18 means 1/3 times 18. So if they put 3/4 times 24, it's asking you for 3/4 of 24. So the problem is essentially the same. So my total is 24. I'm dividing them into 4 boxes, the denominator. And I'm asked for 3/4. I'm looking for 3 of these boxes. Okay, well, again, 24 divided by 4 boxes. What goes in every box? A 6. I'm asked, though, for 3/4. I'm looking for 3 of the boxes. So 3 times 6 is 18. So 3/4 of 24 is 18. Okay. Hopefully so far so good. Okay, now I'm asked for 3/8 of 24. My total is 24 again. This time I need 8 boxes. And I'm looking for 3/8. So I'm going to mark that on my tape so I know what I'm looking for. 3/8. Okay? Well, again, at this point, 24 divided into 8 boxes. That means I need a 3 in each box. And I'm looking for 3/8. 3 of the boxes. 3 times 3 is 9. So the answer is 9. Notice on my work here, 8 divides into the total. 8 divides into 24 3 times, and 3 times 3 is 9. Notice that. That's how I do those mentally, by the way. Look at this one. 4 divides into 24 6 times. That means a 6 was in each box. 6 times 3, 18. Good way to do mental math. We'll keep practicing that. Okay, the next one. My total is 25. Okay, so I'm going to draw my box, label my total. Notice I have fifths, so I'm breaking it into 5 boxes. And I'm looking for 4/5, so I'm going to mark that on my tape with a question mark. That's what I'm looking for. Okay, again, what goes in every box? 25 divided by 5 boxes would mean a 5 in each box. And notice what I'm looking for, 4 groups. 4 times 5 is 20. My answer is 20. Again, mental math, 5 divides into 25 5 times. 5 times 4 is 20. Okay? Next one, we have some bigger numbers, but it's not that bad. We need 7 boxes this time. And my total is 140. And I'm looking for 1/7. Okay, well, 140 divided by 7. Well, 7 goes into 14 2 times, but I have 140, so 2 10s, 220 would go in every box. But notice I'm only wanting 1/7, so that's only one of the boxes. So the answer is 20. Again, 7 goes into 140 20 times. 20 times 1 is 20. Okay, now these two are a little bit different, and you'll see why in just a second. My total on this one is 9, but I'm looking at fourths, and I'm looking for 1/4. Now, why would I say this one's a little different? Well, when I go to decide what goes in each box, 9 divided by 4, that doesn't divide out evenly, but I can still do it. Okay, I just have mixed number, fractions. 4 divides into 9 2 times with 1 left over. 2 1/4. That means 2 1/4 goes in each box. You can do that. And I guess you wouldn't have to write all of that out, but I did to show you. I'm looking for 1 box, so the answer is just 2 1/4. Okay, let's look at the next one. My total is 12. And I'm dividing it into fifths. So I have 5 boxes and I'm looking for 2/5. So I will mark that with a question mark. Okay, so then I go to decide, well, what goes in every box? 12 divided by 5 boxes, that doesn't divide evenly. So I'm gonna have a mixed number. 5 goes into 12 2 times, just 10, so I have 2 left over. 2 2/5 goes in every box. Okay, but I'm looking for 2 boxes, okay? So I just add these together, okay? 2 plus 2 is 4. 2/5 plus 2/5 is 4/5. Okay, so the answer is 4 4/5. Okay, so even if it doesn't divide evenly, you can still do the math. Okay, these two I have stars by because sometimes kids will read them too quickly and not do them correctly. I want you to look at how these are different than what we've been doing, okay? Up here, we knew what the total was, okay? Notice the total was the number after the word of 18. And even though it switched to a multiplication sign, of 24. These were the totals. Now look at this problem. 2/3 of a number. I don't know it. That's what I don't know. I don't know the total, but I know that 2/3 is equal to 10. 2/3 of that number. So look, I'm still going to draw the tape, okay? I'm still going to do thirds. I'm going to mark 2/3 on my tape. But when I go to put the total, I don't know the total. That's what I'm looking for. Remember, the number after the word of is your total, and I don't know it. But I know that 2/3 of the total is equal to 10. So look where I will label that. These 2 boxes, the 2/3, that's equal to 10. Now, if you are looking at that tape, how can I decide what goes in each box? Well, I can see that 2 boxes are equal to 10. Okay, so that means 10 divided by 2 boxes is 5. A 5 goes in every box. So it's easy to see, well, what's the total? 5, 10, 15. The number is 15. That's the total. 2/3 of 15 is 10. Now look what I just said. 2/3 of 15 or times 15 is 10. Remember my mental math? 3 divides into 15 5 times, and 5 times 2 is 10. Works out. Okay, let's look at this other one. 3/4 of a number is 24. Okay, so I draw my tape. I don't know the total of a number. I don't know it. But I know that 3/4, 3 of these boxes, I know is equal to 24. You have to be very careful. Okay, so then again, I look at that and I say, okay, I see 3 boxes equal 24. Okay, 24 divided by 3 boxes, that means an 8 would go in every box. So if I fill an 8 in every box, I can see what the total is. The total is 4 groups of 8, right? Which is 32. My total is 32. Okay, again, if I go back and check that, that means 3/4 of 32. I'm saying that's equal to 24. Let's check. 4 goes into 32 8 times. 8 times 3 is 24. Sure enough, it works. Check. Okay, on to the back. We got some good word problems today. Okay, there are 48 students going on a field trip. 1/4 are girls. Okay, I'm going to stop and draw that. Okay, 48 students. 1/4 of them are girls. I'm just going to put a G for girls. That means I guess the rest are boys. Okay, so we'll label that too. Okay, how many boys are going on the trip? That's what I'm looking for. So I put my question mark. Okay, well, I can see on this tape. Tapes kind of just reveal the math, I think. They reveal what you're supposed to do. 48 divided by 4 boxes would mean a 12 goes in every box. So I can see, there's 12 girls. But it's asking how many boys. So 3 times 12 would be 36 boys. All right, so that one was pretty easy. This next one is a challenge, and I love it. I love geometry. Okay, I see angles and degrees. It says 3 angles are labeled below with arcs. Okay, that just means this, an arc. It's labeled this angle is 160. This angle, I don't know. It's a little one. And this angle is A, angle A. All right. The smallest angle, which is this one, is 3/8 as large as the 160-degree angle. Find the value of angle A. So we won't worry about that yet. Let's look at this part, okay? The small angle is 3/8 as large as 160 degrees. So if I think about a tape, that's 160 is the total, and I want 3/8 of it. That means I'm thinking, okay, I divide that into 8ths. And there's 3/8. Okay, well, 160 divided by 8 boxes would be, 8 goes into 16 2 times, so it would be 20 in each box. So I can see that 3/8, 3 boxes, 3 times 20 would be 60 degrees. Okay, so the smallest angle is 3/8 as large as the 160. So the smallest angle is 60 degrees. I'm going to label that. Okay, now we're supposed to find the value of angle A. Well, you have to know something very important right here. How many degrees are there in a complete circle? Okay, when somebody says they're going to do a 360, have you heard of that? That means you'd spin around one complete time. There are 360 degrees in a circle. Really important to know. Okay, well, that means if this much is 160 and this much is 60, how much is left to complete that circle? Well, 160 plus 60, if I just add that up right there, 6 plus 6 is 12. That would be 220 between these two. So what's left for this angle? Well, 360 minus 220 would be 140 degrees is equal to A, angle A. right, that wasn't that bad. Good stuff. All right, 2 more problems. Abby spent 5/8 of her money and saved the rest. Okay, I'm going to just stop right there and draw a tape with 8 boxes. And I'm even going to say, okay, 5/8, 1, 2, 3, 4, 5. It says she spent. Okay, she spent 5/8 of her money and saved the rest. And notice I don't even know the problem, but I've got a picture for it already. All right. If she spent $45, now you have to be careful. 45 is not the total of this tape. It says she spent 45. So look, where I have spent, I'm going to put $45 right here. How much money did she have at first? That means I'm looking for the total. Well, let's look. 45 represents 1, 2, 3, 4, 5 boxes. Okay, so 45 divided by 5 boxes would be a 9 in each box. So if I want to know the total of the whole tape, that would be, how many boxes were there? 8. 8 groups of 9 would be $72, would be her total. All right, last one. That was like those 2 on the front that I put stars on at the bottom, and it was like that. Okay, last problem. Mrs. Harrison used 16 ounces of dark chocolate while baking. I love dark chocolate. She used 2/5 of the chocolate to make frosting and used the rest to make brownies. Okay, I'm going to stop right there and just draw what I know. Okay, so it's talking about fifths. So I know I need 5 boxes. Okay. I know that 16 ounces of dark chocolate is what I'm talking about. OZ is ounces, by the way. 16 ounces. She used 2/5 of the chocolate to make frosting. So I'm going to label that. 2 of the boxes is frosting. And the rest she uses to make brownies. So I have a good tape so I can see what's going on. Now, how much more chocolate, when I see that phrase, I know I'm going to be subtracting, by the way. How much more chocolate did Mrs. Harrison use in the brownies than in the frosting? Okay, well, I can see that she used more in the brownies than the frosting, right? But I need to know exactly how many more ounces more did she use, okay? So I need to figure out the ounces for the frosting and the ounces for the brownies and subtract. Okay, well, again, when I go to figure out what goes in every box, I have 16 divided by 5 boxes, and that doesn't divide out evenly, but I can still do the math. 5 goes into 16 3 times with 1 left over. Okay, so I have 3 1/5 is what goes in every box. Okay, so we can handle this. Well, if I figure out, well, how much is used in frosting? Well, add 3 1/5 and 3 1/5. Okay, so that would be 6 whole and 2/5. Well, for the brownies, I can add the whole numbers, 3, 6, 9. 1/5, 1/5, 1/5, that's 3/5. Okay, so how much more was used in the brownies than the frosting? And sorry, that's a 3. I didn't do that well. Well, I would subtract 9 3/5 minus 6 2/5. If I subtract 3/5 minus 2/5 is 1/5. 9 minus 6 is 3. So 3 1/5 ounces more was used in the brownies. All right, there we go. Not too bad. So you can move on to the homework. Hope you have a great day.